In the late 1930s, Hitler faced a problem no conventional weapon could solve: the Maginot Line, millions of tons of reinforced concrete buried deep underground. His directive to Krupp was simple: build something that could. What they delivered weighed 1,300 tons, fired 7-ton shells nearly 50 kilometers, and required 4,000 men to operate, the largest weapon ever built. But size alone wouldn't decide whether it was worth it. Adolf Hitler's vision for a weapon that could obliterate the Maginot Line was not simply a passing fancy. In 1937, the Kanzlei Minutes record his willingness to devote any resource necessary to break the French concrete barrier, a demand that landed squarely on the desks of Germany's top industrialists. Fritz Todt, the Reich's armaments minister, pushed the concept through the labyrinth of military bureaucracy, but it was Wilhelm Rudenauer at Krupp who was handed the task of turning Hitler's fantasy into steel and fire. The numbers alone defied belief. Krupp's initial design sheets, stamped with the company's blue insignia, called for a gun weighing 1,350 tons, more than a dozen modern diesel locomotives combined. The barrel would stretch 32.5 meters, longer than a blue whale, bored out to a monstrous 80 centimeters in diameter. Each shell would tip the scales at 7 tons, nearly the weight of a city bus, and would be hurled up to 47 kilometers, far beyond the reach of any existing artillery. These were not just engineering figures, they were a declaration of intent. The weapon would need a workforce of thousands to assemble, operate, and protect it. The shell alone required a special crane and a loading crew of 150 men, all working in perfect sequence to prepare a single shot. In the archives at Krupp, the correspondence between Rudenauer and Todt reveals the pressure behind the project. Hitler's personal interest meant deadlines were absolute. Every delay was scrutinized at the highest levels. The gun was not just a technical challenge, it was a political mandate. The ministry's budget earmarked 5 million Reichsmarks for the prototype, with promises of more if the design could deliver the shock and awe the regime craved. Internal memos show that even as the gun's blueprints grew in ambition, so did the logistical headaches. The Army's procurement officers warned that the steel and labor needed for Gustav would come at the cost of tanks and aircraft. But Hitler's word overrode all objections. By early 1939, the project had outgrown the confines of Krupp's Essen plant. Special flat cars were commissioned to carry the barrel and carriage. The Deutsche Reichsbahn was ordered to prepare rail lines strong enough to bear the weight. Every detail, from the hydraulic recoil system to the custom-forged breech ring, was pushed to the limits of what German industry could produce. In Rudenauer's diary, he wrote of the internal stresses beyond any previous experience, a nod to the unprecedented scale of the task. Yet for all the technical prowess on display, the weapon's purpose remained fixed: to break the unbreakable and to prove that German will could be measured in tons, meters, and megajoules of force. The blueprint was now reality, but the question lingered: could even a weapon of this size truly change the outcome of a modern war? 70 reinforced railway wagons left the Krupp works in Essen, each loaded with steel and machinery, moving at a crawl behind 10 locomotives. The convoy stretched over a kilometer, a rolling industrial column that strained every bridge and tunnel along its route. Every axle and coupling bore the weight of the heaviest gun ever built, Gustav's barrel and cradle inching forward at 8 kilometers per hour. Arrival marked the start of a logistical operation as daunting as any battlefield maneuver. On site, more than 4,000 workers transformed open ground into a fortress of concrete and steel. Railway engineers, laborers, and Wehrmacht pioneers poured foundations, laid steel sleepers, and built a firing platform 40 meters wide and 30 meters deep. Assembly, recorded in diaries and technical logs, took 6 weeks. The carriage was anchored to a slab of reinforced concrete. Gantries from Esslingen lifted the barrel into its cradle. Hydraulic lines snaked across the site, buffers were tested, and the massive breech ring was bolted into place. Precision ruled every step. A single misalignment could ruin months of work. Gustav's size created a new challenge. The barrel, fixed in its cradle, could not traverse left or right. To aim, the entire gun had to move. German railway engineers answered with a curved segment of track, hundreds of meters long, set in a gentle arc. By shunting the 1,350-ton gun along this curve, crews could adjust the firing angle up to 30 degrees. Each movement was logged, the arc of rails acting as a massive aiming dial. Calculations for the curve's radius, friction, and the settling of concrete had to be precise before a single shot could be considered. During final preparations, the workforce peaked. Pioneers in field gray uniforms laid camouflage, built dummy sites, and flooded ground to confuse enemy reconnaissance. Fitters, machinists, and railwaymen worked in shifts, hands blackened by oil and dust. The gun dominated the landscape, a mountain of steel atop a ribbon of track, surrounded by ceaseless labor. By assembly's end, the logistics tail stretched for kilometers. Fuel, water, ammunition, spare parts, and food arrived daily. Every shell, every tested hydraulic line depended on the discipline of this vast support network. Gustav stood ready, its barrel aligned by the sweep of curved rail, a monument to industrial ambition and mechanical rigidity. In late May 1942, the Crimean rail lines carried Schwerer Gustav to the outskirts of Sevastopol. The journey ended at Cameroon Hill, where the gun's arrival signaled the start of a siege unlike any other. For 10 days, the crew and thousands of laborers worked around the clock, piecing together the weapon's massive components on a foundation of concrete and steel. The curved track, laid out in a gentle arc hundreds of meters long, allowed the entire gun to be nudged left or right, each movement measured, logged, and checked. Locomotives shunted the 1,350-ton monster into position, while teams of pioneers checked the alignment and recalibrated the fire control optics. By mid-June, the weapon stood ready. The barrel, 32.5 meters long, pointed toward the southern edge of the city, where Soviet bunkers and coastal batteries formed a labyrinth of concrete and earth. The gun crew, drawn from elite railway artillery regiments, rehearsed the firing sequence in silence. Each shell, 7 tons of steel and high explosive, was hoisted by crane, rammed into the breech, and sealed with a click that echoed across the site. The loading cycle took nearly an hour, every step overseen by officers with stopwatches and checklists. On the morning of June 22, 1942, the order came down. The gun captain gave the signal, a deep metallic groan, then a thunderclap. The ground trembled as the first shell left the barrel, arcing over the city toward its target. The impact tore a crater 12 meters wide in the Soviet battery at Cape Chersones. German observers recorded the shockwave, and Soviet reports later described the sound as a volcanic roar. 4 more rounds followed in the days ahead, each one demanding the full focus of the entire crew. Between shots, the gun cooled, the rails were checked for stress, and the next shell was prepared. For the men on the ground, it was both a feat of coordination and a test of endurance. Yet even as Gustav's shells shattered concrete and sent tremors through the city, the Soviet defense lines held. The weapon had arrived, fired, and left its mark. But the battle for Sevastopol would be won by other means. The firing of Schwerer Gustav at Sevastopol left behind a record measured as much in resources consumed as in shells fired. The gun's rate of fire, 1 round every 30 to 45 minutes, was dictated by its immense scale. Each shot demanded a full crew of 250 specialists and a support network of thousands more, all overseen by officers with strict timetables. In the span of the Crimean operation, only 5 combat shells were fired, with 2 more expended in calibration. Of the roughly 100 shells produced by Krupp's dedicated line, most never left their storage crates or were destroyed to avoid Soviet capture. Budget sheets from the Reich Ministry of Armaments show an outlay of 5 million Reichsmarks for the prototype alone, not counting the cost of ammunition, transport, and assembly. Internal reports from the OKW reveal growing frustration as the true burden became clear. The steel and labor devoted to Gustav could have produced dozens of tanks or hundreds of aircraft. The logistical chain, rail lines, cranes, fuel, and security required a level of coordination that rivaled entire divisions. The gun's complete immobility meant it could only be used in static sieges, while the war's pace had shifted to rapid, mechanized movement. Archival memos from Krupp engineers and Wehrmacht planners questioned the return on such an investment. One board minute, dated July 1942, notes that the psychological effect was undeniable, but the material cost outweighed any tactical advantage. Historians reviewing these records have pointed out that Gustav's operational impact was limited to a handful of destroyed bunkers. The battle for Sevastopol was ultimately settled by combined arms and infantry, not by the world's largest cannon. In the end, Schwerer Gustav stood as a monument to ambition and excess, a weapon built to break fortresses but unable to break the course of the war. Gustav's shadow lingers, a monument to ambition outpacing reason. Today, nations still chase ever larger arsenals, often forgetting how spectacle can eclipse true strategy. The world's most massive gun left craters in the earth, but not in history's outcome. The lesson? Scale alone never decides the fate of war.